In this video, Dr. David Francis from The Ohio State University demonstrates steps to combine two datasets using merge function in R. The video also emphasized the importance of data labeling standardization when combining files using R software.
Let's talk about the data a little bit. We've been working with tomato data, but this could be any crop data. Each plot is a unique number every year. Year and plot is a unique designation over the history of a program. Okay, and so plot numbers then get tied back into the experimental design, whether it's a randomized complete block design or an augmented design. So plot number is allowing us to link information. When using this approach, there's a need for standardization, and I'm stating the obvious in a way, but it's important. So when you're using a computer to merge data, we have to be consistent. The computer is not going to recognize OH8245 with O and H capitalized. It's not going to recognize that the same as O and H lowercase or OH with an underscore or OH with a space, right? So if we want the computer to treat these as a single genotype, we need a single name. So that's important. This is what our data is going to look like. It's a list of genotypes and then the fruit number, best linear unbiased predictors. This is our phenotypic data now. Let's talk a little bit about our molecular markers. We've got different platforms we can use. In our case, we're going to be working with some Infinium data. It's Beat Express data. So we had 384 of these Infinium SNPs converted to Beat Express platform and then scored them using the AB format on the Illumina software. So this is what our data looks like. Okay, so the markers you can see in this case are scored A, B, and H. They could be scored numerically. They're just not in this data set. And again, I think I need to point out that missing data is coded as NA. We can go ahead and open up R and open up the script. So the first thing I'm going to do is I'm going to set the path. Then I'm going to read in my data. I can check that data. So for this particular file, head and tail would be good commands. So I just want you to notice one thing, right? The file that we wrote out would have looked like this. I renamed them to give them these designations. And that's a nice little exercise, is to see if you can figure out how to do that automatically with R. So we look at the structure of that. We've got 280 observations of two variables, genotype and fruit number. Then we're reading in this other file here. That file has 122 observations of 263 variables. What are we looking at here? So why the difference? Why does one have 280 observations and the other only 122? What's the reason for that? How many markers do we have? So you see this line that says 263 variables? Okay, so one of those is genotype, one is pop, and everything else is a marker. So I have 261 markers. So we originally started with 384 markers, but some of them weren't polymorphic. Okay, so we only included the polymorphic markers. So we've got a population of 122, and we have 261 polymorphic markers. I want to merge these two files by genotype. And so the command to get me there is listed here. I have 120 observations. So that means that two genotypes dropped out because they weren't in the marker file or they weren't in the phenotypic data file, one or the other. Okay, I have 264 variables. So I have genotype, I have fruit number, and I have population. So I still have 261 markers. So this makes sense. I've got a new data frame. It's called D3. It's got my markers. It's got my phenotypic data. It's got everything I need. Okay, so I've taken two files, I've merged them, I've created a single file.